Okay, here we go. The last class period we learned the following. Last time we met, we learned that if we're asked to compute an integral and we don't have a calculator, so we're not able to plug the black formula into a calculator, what we must first do, according to the fundamental theorem, is we must find the antiderivative of that black formula. So we're trying to find the antiderivative of this item right here that I'm now circling in black. Once we have that antiderivative, we can plug into the antiderivative the two limits, and then we can find the value of the integral. So we're using the fundamental theorem right here. We're trying to find the integral of some formula. It doesn't matter what we call that formula. So just some formula here, circle it in black. The fundamental theorem says if you can't put that black formula into a calculator, go find the yellow formula instead. And with the yellow formula, plug in these limits, and you can calculate the value of the integral. So Hunter, how is the black related to the yellow?
It's the derivative of the yellow.
So the black is the derivative of the yellow. Therefore, Hunter, the yellow is the antiderivative of the black. 3 points for Hunter. So we're looking for the antiderivative of this thing here. So we go straight to our blue rule sheet, and we go to Maddie on the front here. And Maddie looks at her blue rule sheet and says, yes or no, is there something on the blue sheet that looks just like that orange box?
Yeah.
So which one are you looking at, Maddie, that feels like it's a match for the orange?
Well, it's kind of cute, like the power rule and the exponent.
That's very good. It looks like the power rule and the exponential rule. So that means there isn't a single formula that looks exactly the same. Like, we don't have a rule that says we can use the formulas in combination. So we're stuck. We don't have a match. Questions? Okay, if you don't find a match on the, now I'm teaching you a method that is valid for calculus AB. If this were BC, we would have to expand this conversation by quite a bit. So if you take Calc 2, be prepared for additional ideas that add on to what I'm saying. But for our class, this works really well. Nothing on the blue matches, so you can't use the blue. So our next thought is to do what's known as a U substitution. The complete name would be, we're going to find the antiderivative using a substitution, or substitutions. And the way we do it is we have a set of guidelines here to kind of help us think through the process. Now they are guidelines, meaning you'll see me violate them at times because they're not strict rules, they're just trying to help me kind of get going. So I can't use the blue sheet. So instead I look at my situation and I try to notice if I have two functions being multiplied. So we'll go to Gideon. Right here, Gideon, would you say it is fair to say that we have two functions being multiplied?
Yes.
What are the two functions being multiplied?
X cubed and e to the x to the 4. 3
points. So we have this green formula x cubed, or sorry, blue, and then this green formula e raised to the x to the 4. So we've done this. We've got two functions being multiplied. Questions about anything? Okay, go back to where we're trying to get to, is we are looking for the antiderivative of this yellow formula because we were unable to plug the yellow formula into our calculator. So we're looking for the antiderivative of the yellow. We couldn't find the antiderivative of the yellow using the blue sheet, so now we're doing this substitution process. This will feel a little bit like, what are we even doing? But we'll practice enough that it gets more comfortable, okay? Let's go to Anna. So Anna, we look at that blue formula. It says that both functions are supposed to be of the form right here. Something to a number, e to the something, 1 over something, sine of something, or cosine of something. The blue one is which of those 5 forms? It's definitely the first. What's the n?
3.
Okay, this little dotted box, is what I refer to as the something. So that first formula is something to the third. What's the something? X. It says right here we're doing a U substitution. We should pick the U always as the something. Okay? So that means that blue formula, the value of U would just be U is equal to X. Now you want to make sure you write some things on this side of the page and you write some things on this side of the page. You need to keep your work organized, otherwise they won't be able to help you. Questions? Cool, 3 for Anna. So let's keep going. Get rid of this. Okay, please memorize the following idea. We're trying to find an appropriate value for U so we can make a substitution. If we discover that U could equal X, that's useless. It's of no value that they are the same thing. So we don't really ever do anything with that. We just note that that didn't help anything. Okay? So don't do that. Questions? Cool. Let's go to Olivia. So we looked at the blue function. That didn't really help, so we're going to look at the green. So Olivia, the green function is which of the 5 forms?
Second one.
Second one. What's the something for the green?
X to the 4.
Perfect. So I write that down, 3 points for Olivia. So far so good because it's not just U equal X. So we keep going. The next thing, so we did that, we've done this. Oh, right here, got both choices, differentiate. So we'll go to Kate, differentiate both choices for U. So I apply the ddx operator to both halves. So the left half is just du divided by dx. Kate, using the old green rules, what would we rewrite that as?
4. And then 2 substitutes.
So I go 4x cubed, 2 points for Kate, dx dx. Or just 4x cubed. Okay, questions from anyone? Again, if it feels like you have no idea where we're headed, that's normal. I don't expect you to know at this point, okay? But as long as each step is logical and legal, we're doing fine. Pretty good? Cool. Go to Ethan, Valletta. Okay, Ethan, this choice of U came from which of the 2 multiplying functions? We had 2 multiplying functions. We made a choice of U by choosing something from one of them. So where did the green choice come from, Ethan? Good. So the green choice came from the green formula there. The derivative of our choice, right here. You can ignore the 4 because it's just a multiplying constant. Is the derivative of our choice exactly the same as the other multiplying function? Other than the 4, exactly the same, 2 points. That's really good news. That means this is highly likely to be the correct choice for you. 2 points. Please, Jessica.
Wait, why could you just say like minus, like just don't look at the 4?
Ignore the 4.
Yeah, like,
I'll have you help me and you'll see why it's perfect. So it's called U substitution. Jessica's going to get a ticket for this because it's kind of a long thing, but she's exactly where we want to be in our thinking. It's called a U substitution because we're going to keep replacing things. We're going to substitute. Substitute means find things that are equal. So looking over here, so you're comparing the 2 columns, Jessica. What is exactly the same? Like there's something here that's exactly the same over here. Like I noticed that this says x to the 4th. And this says U is the same as x to the 4th, so they're the same. So I can replace them. With me?
yeah.
Okay. We've got to make other replacements as well. Let's do that first. We're going to write equal. 0 to 1, x cubed, e to the u, dx. Jessica, these two are multiplying, yes?
Yeah.
When you multiply two functions, is the order important or unimportant? Unimportant, so we can switch them. So I will switch the order. Okay, now here's your question, Jessica. I would like to replace this also with something else. So I come back over to here where I find the replacements, and I look at this equation. This is one thing divided by another. This says 4x cubed. Like, everything I need is here, it's just in the wrong order. Because I need x cubed times dx. Can you see of any way to make this look like x cubed times dx?
You'd have to get the 4 out of there, but I don't know.
No, it's perfect. Because your question was like, why did I not worry about the 4?
Yeah.
So it's just an equation. Like, don't think of it as anything different than, say, you've got a over b. You're really doing well. That's why I'm paying you a ticket. You've got a over b is equal to 4 multiplied by x cubed. We want to get the x cubed more by itself, right? So what would you do to both sides?
Divide by 4.
Are you okay that dividing by 4 and multiplying by 1/4 are the same?
Yeah.
So I'm going to go 1/4 a times a over b is equal to x cubed. I'm making progress because now I'm more like what I have here. That's the x cubed. That's why I didn't really worry about the 4.
Okay, yeah.
You with me?
Yeah.
Okay, so ticket for Jessica. So Ian in the back. Back to here, Ian. I want to get, I want to not just get rid of the 4. I want to somehow write x cubed times dx.
Yeah, you multiply by dx.
So I multiply the dx. So I get du times 1/4. Exactly the same thing as x cubed multiplied by dx. Which means this purple box, which is right here, is exactly the same as this purple box. So I can make a replacement. So I come back over to this side and I write. Ian, does this 0 represent a value of x or a value of u?
X.
It's x. It came from here and here when they were values of x. We haven't done anything to change them. So for emphasis here, we're going to write x equal 1. That's terrible. And x equals 0. And we have e to the u. And Ian, what do I write in place of x cubed dx?
1/4 du.
Because they are the same. Equal means you can use either one.
Do you parentheses around it?
Wouldn't hurt because sometimes it's a negative. And if there's a negative, it's critical that we have parentheses. So we just make the replacement like that. Questions? Questions about anything? Everybody good? Maddox, go ahead.
I think I'm good.
Okay, keep going. Really, if it feels like we don't know what we're doing, it's really okay. All that's important at this moment is that you are confident that we've not done anything illegal. Like everything we've done is following a logical equal sign. Like we have said, this is the same, so we can change it. Everybody good? 2 for Maddox? Okay, so let's go to Ethan Jensen here on the front. Oh, wait a minute. We need to change these here from x values into values of u. We have a formula that says how x and u are related, right here. So a nice way to organize your thinking is to just make a little table and say, okay, just want to compare x values to u values. So over here we have a value of x that is 0. So here's a value of x that's 0. According to this, Ethan, if x is equal to 0, what would u equal?
Would that equal 0?
Also 0, because it says the u value is nothing more than the x value to the 4th.
Yeah.
So definitely 0 there. So when x is 0, u is also 0. When x is 1, Ethan, what would u equal?
Just 1.
Just 1. Same reasoning again. The u value is nothing more than the x value to the 4th. So when x is 1, u is also 1. So we can make another change. Ethan's going to stay with me here. So we can now integrate from u equals 0 to u equal 1. But just like derivatives, 1/4 is a multiplying constant. We can pull it out. With my equal sign, 1/4 e to the u du. Questions? Please.
Or did you need to change the interval x values to b values?
I will be honest with you, there are two different ways this problem can be solved correctly. But if we use the other method, I have seen AP questions that can cause, like they can trap you into the wrong answer. So I like to tell a silly story that a student told me. It helps you remember. It's silly. The student said, "Oh, I get it. Look, this whole process, it's like dating. Like you find, you meet somebody and you like, I want to spend some time with them, and you spend some time and get to know them better. But it's not uncommon to, after a while, kind of realize that it's time to go meet somebody else and leave them behind. And so you create what's known as an X, right? Like you have an ex-boyfriend, ex-girlfriend. Smiling is good. So look. So we start, no, I'm serious, this works really well. You start the problem, it's all about the x. But that's kind of the problem to begin with, is like it became too much about the x and not enough about you. It's a good story. Stay with me, it's good. Okay. So, like the Taylor Swift song, there comes a point where it's time to burn all the pictures, okay? And just move on. Like, look, I'm serious. Like, leave your ex behind. So what we did, look, we had a problem with our ex. I tell you, the story fits so well. We had a problem with our ex. It just was not working out. We've changed everything. Like, we've just, forget it. I'm just going to make it about me. It's all about you. Look here. Everything's about you. Everything. There are no exes. The pictures are gone. Like ashes, okay? Ashes. The picture has been burned, okay? So we've gone, forget about the X, it's all about you. I promise this is the method you want to use. It works best. So I'm not giving you a real good reason why, but it is why we do it. So. Are we good?
Yeah.
Okay, I'm going to pay 10 points for everyone who'll do the following. Grab your calculator, 10 points. Be honest about it, of course. Type in this integral. Raise your hand when you have it. Tell me what decimal you get. So type in that integral. Tell me what decimal you get. So Claire's got, what do you get, Claire? 0 point what? 4.3. Is there a third decimal? I always want to do 3. 430. The 0 is important because it actually is rounding. Raise your hand if you got that. Hands up. So that's 5. Mark down 5. 5 more to come. Now type in this integral. And they should be the same if we haven't made an error, because they are equivalent. They're equivalent integrals. So type in that one. Andrew, you got it? Same thing? Perfect. And you could actually change your rounding to like 10, and they would match every single decimal. Or like, well, I got that could be lying because the calculator is doing some approximating, so I better not say that. They might have some differences. But they're theoretically the exact same. And how many got it? 5 more. Mark it down.
Can you tell me what I did wrong?
Yeah.
We both got the same.
You're good. Oh. So I'm using the letter D. Do Anybody else? Need help? Please.
I don't know what I did wrong.
Let me look. Yeah. See. Okay. How many got it to work? Hey. Man. How many got it to work? Show me. Show me. Show me. Okay, good. That should have been 5 points. We got it to work. Okay, look. We'll go to Carrie Ann. Quiet. No one talk. Okay, so in the very beginning, Carrie Ann, continuing the story, we were making life too much about the X. Yeah, not a good choice. Too much. 1 second. So we're making life too much about that. But our goal was still the same. We couldn't type that in our calculator, so we needed the antiderivative of this yellow stuff, right? We couldn't find one on the blue sheet. So we did this U substitution stuff. We created a brand new integral, which is equivalent. We proved that.
Mr. Smith,
Yeah.
Ian Sanchez is being checked out.
Okay. Sorry, look, I'll get to you. My bad. Hey. Look. So we have a new integral. No one talk. We have a new integral. We still can't put it in our calculator. So now we need to focus on this. And what are we trying to find at this moment, Carrie Ann?
Are you trying to find the antiderivative of that?
Perfect. Look, come on, look. We need the antiderivative of the orange. Carrie Ann, look at the blue sheet. Do you see any boxes on the blue sheet that look exactly like this orange box?
The exponential rule?
The exponential rule, so we can find the antiderivative. So what is the antiderivative of e to the u according to that blue sheet, Carrie Ann?
E to the u plus c.
Perfect. So we get e to the u. We don't need to worry about the plus c. Last time we talked about how that will just subtract out anyway. 3 points for Carrie Ann. Questions? So you have the blue one already. It's right here. You're good. Don't worry. You can have a sheet protector. It's fine. Olivia, you had an earlier question. I didn't mean to.
Oh, yeah, when did when did that change to U? I thought it was e to the 4 right there.
Oh yeah, it does look like a 4. You're okay. Where we changed that was back here when we said, according to our guidelines.
U equals x to the 4.
Right, you see it?
Yeah.
You're good. 2 more. Anybody else? Good? Sweet. Okay. So this means just plug in the numbers now. So we're at 1/4, parenthesis, e, take away the u, plug in a 1, subtract, take away the u, plug in a 0, Maddox. E to the 0 is the same as what number?
1.
Good. E to the 1 is the same as what number, Maddox?
0. Not 0.
No worries. Something to the first is just itself. So e to the first is just e. Okay with that? So we're done. 2 points for Maddox. Questions? Type this in your calculator, please. Type that in your calculator. Jake, what do you get?
430.
Nicely done. You got .430, give yourself 2 points. 3 for Jacob. Questions? Cool, let's do another one. So, done with that. Stop that video.